Hi guys, welcome to this video. I've got a really good prove that question on trig identities, followed by another part to this question, which is integrating this. So I've taken this question from Madas Maths, and I will put a link down below if you want to explore that website and also look at this question in a different way, because I've tweaked the original question to make it a bit more realistic, as this is more likely to come up in an exam compared to the original question. I believe it was worth 12 marks, and we tend not to get 12 markers in at Excel maths or even AQA maths for that matter. So let's get cracking with the first part of this question, where we have to prove that 32 sine x sine 2x sine 3x is equivalent to 8 times sine 2x plus sine 4x minus sine 6x. So I'm going to start off with the left-hand side. As always, I do prefer to start with the left-hand side. And for this particular question, what I notice is A, obviously everything is in terms of sine, and B, there is a plus in the middle or a minus in the middle on the right hand side compared to all times in the left hand side. So my aim will therefore be to introduce the use of trig identities such as addition formulae as well and double angle formulae to help me solve this question. So let's start with the addition formula of sine 3x. Okay, so sine 3x can be written as sine of 2x plus x, all right? And for that, it is just sine of 2x cos x plus sine of x cos of 2x. So I'm going to introduce that into my left-hand side. I'll keep the rest as it is. So 32 sine x sine of 2x. Make sure you have a bracket, and it will now be expanded. Okay, so carefully expand this, all right? So 32 sine x cos x and sine squared 2x plus 32 sine squared x sine 2x cos of 2x. Okay, now we know that there is a double angle formula for sine 2x, which goes like this. That's 2 sine x cos x. Okay, and so if I just carefully factorize this 32 into perhaps 16 times 2, I can then replace the 2 sine x cos x by the double angle. Okay, and similarly on the other side, this sine 2x cos 2x, again, if I just put it as sine 2x cos 2x, sine 2x cos 2x, I can also replace that by sine of 4x. Okay, as you double one side of the double angle formula in with respect to the angles, you must double the other side as well with respect to the angle. Okay, only the angles though, not any numbers in front. So 16 times by, this becomes sine 2x, and I'm going to avoid multiplying these two because it will give me a cubic term, and I'm not looking forward to solving that because that's not what I want. I want singular, like the power should be 1. Okay, so I'm going to avoid multiplying them two together. And then I'm going to have 16 times sine of 4x sine squared x. Okay, so my aim is to get rid of the squared terms, and the only way I can do that is using the double angle formulae. And I know that the double angle of, well, cos, so cos 2x helps me with that. So cos 2x is equal to 1 minus 2 sine squared x. Okay, so again, I'm going to quite cheekily factorize 16 again. Okay, so 8 sine of 2x 2 sine squared 2x. Okay, and then I'm going to have plus 8 of, again, I can do the same over here with respect to sine squared x. So 8 sine of 4x 2 sine squared x. So again, as I said, if you double the angle on one side, you must double the angle on the other side. So to replace 2 sine squared 2x, it will become basically, that remains the same, 1 minus cos of 4x. Okay, just rearranging this bit basically. That's all I'm doing. And then similarly for the next bit, it will be 8 sine of 4x and then 1 minus cos of 2x. So now from here, all I've got to do is expand and simplify. So I'm going to have 8 sine 2x minus 8 sine 2x cos of 4x plus 8 sine of 4x minus 8 sine 4x cos 2x. And now from here, if you notice, we've got almost there. We've got the 8 sine 2x, okay, which is there in the answer. And we've also got 8 sine 4x. We just need to sort out the other bit, which is minus 8 sine 2x cos 4x minus 8 sine 4x cos 2x. And if I just say it out loud to myself, you'd probably also notice that this becomes the addition formula of sine 2x plus 4x. Okay, so if I just take out the 8 out, okay, so minus 8, you'll see that if I write this together. Okay, so I'm gonna have, that's a 4 sine 4x cos 2x. Okay, so hopefully now you can see it, that this is actually minus 8 sine of 2x plus 4x, which gives me my final answer, and that's just 6x. Okay, the rest remains the same. So 8 sine 2x plus 8 sine of 4x. And this is my right-hand side, hence I have proved my identity. Is on integrating it. So for part B, we have to hence find the value of the integral of 32 sine x sine 2x sine 3x within the limits of 0 to pi over 3. So this is really easy now, because we've already sorted out the this expression in the form which can be integrated. Okay, remember we can't integrate this, okay, the way it is. So we can use our answer from part A. Okay, now for a question like this where you have two different parts, even if you can't do part A, you still should be able to do part B, because you can simply use the answer from it. So try not to lose the marks, try not to give up saying that, oh, I can't do part B if I don't know A. That's not true. Okay, so let's give this one a go. And I'm just going to write this down into my expression that I found, okay, the right-hand side. So that was 8 of 0 to pi over 3 and sine 2x plus sine 4x minus sine of 6x, and that is to be now integrated. Okay, remember the integration of sine 2x, okay, or if I just write this down as sine of perhaps ax dx is minus cos of ax, okay, over a, and then plus c if there are no limits. Okay, so that is what I'm going to use throughout. So I'm going to leave, in fact, I might as well multiply the 8 within. So 8 times by minus cos of 2x over 2, okay, followed by, again, plus 8 of sine 4x, which becomes, integrated, becomes cos of 4x over 4, so minus, okay, so 8 over 4, and then followed by minus minus, so plus 8 cos of 6x over 6, and the limits are now going to be inserted. Okay, so I have got I'm just going to simplify this first slightly. Okay, so minus 4 cos of 2x minus 2 cos of 4x plus 4/3 cos of 6x. And now I shall place my limits in, and let's see what I get. So I'm going to have minus 4 cos of 2 times by pi over 3. So that's 2 pi over 3 minus 2 cos of 4 pi over 3 plus 4/3 cos of 6 pi over 3, which is basically 2 pi. Okay, so that's my one limit done, followed by my second limit, which is minus 4 cos of 0 minus 2 cos of 0 and plus 4/3 cos of 0. Okay, so all I've got left with now, if I can either use my brains or use a calculator, I will get the same answer. And let's just use a calculator to be safe, okay, then sorry. So I am ending up with, let's find out. So I've got a cos pi over 3, so that is k2 plus, I'm just going to work this out in one go actually. So all that is going to end up giving me, so this bit is going to end up giving me, okay, that gives me 13 over 3. and the other side is going to give me 4 plus, okay, so 4 plus 2 minus 4/3. Okay, cool. So my final answer happens to be 9. Yep, 9. Okay, perfect. There you go. That's my answer. And hopefully this question, the second part of the question, wasn't too hard, but the first question was definitely a juicy one. So as I said, I will link up the original question. You can check it out because the guy who originally did this question did it slightly differently to me, but I preferred it my way, obviously. It doesn't mean that you can't do it any other way. Let me know in the comments below if you want to see more videos like this, where I could potentially cover more questions on integration and trig, only the hard ones, of course, because easier ones you can do it yourself. Anyway, I hope you found this video useful, and once again, thanks ever so much for watching.